Well, welcome to another episode of Let's Learn Algebra Online. So I hope you guys are having a good day. My fiance is laughing at me in the background. But I thought I'd give you a little warm-up on inequalities today, being that our con assignments are all focused around linear inequalities. So, first off, let's talk about our signs. Inequalities, they tell you that you have to have more than one solution, meaning more than one solution satisfies the inequality or makes it true. Now, this statement right here, y is less than negative 1/2 x plus 2. Clearly, if this was just a linear equation, I'd have y equals negative 1/2 x plus 2 with a slope of negative 1/2 and a y-intercept of 2. Now, I'll graph this in the same sense as graphing a linear equation. I'll start at my y-intercept of 2. I'll plot a point. And then I'll move down 1 over 2 to plot my slope. Oops. Let's add another line there. And we'll start to form a line. Now, when you graph your line, you have to think of two things. What type of line are you graphing? And how are you going to shade to represent the solution set? So, first, we'll talk about our lines. A less than or greater than sign will give me a dashed line. And a less than or equal to or greater than or equal to will give me a solid line. Now, in this case, I definitely have a dashed line that I'll have to draw, being that y is strictly less than negative 1/2 x plus 2. So I'll start by kind of tracing in my line. I'll start at my first point, and I'll make dashed lines. Now, on the con assignments, this is already done for you, and you have to determine which graph is correct. I'll also put problems like this on a Regents Review Google form that are Regents level questions where also you'll be given multiple choice answers where you just have to determine which is correct. So there's no actual real graphing that I'll assign to you. Now that I've figured out what type of line I'm using, I have to figure out the shading. Now, anything that's strictly less than y, I'll shade below, or rather y is less than a certain equation. And anything that's greater than, I'll shade above, all the values that are greater than that line. Now in this case, we have y is less than, so I'll shade below. Now, being that I now have a shaded region, I can now test a point in that shaded region to see if it satisfies my inequality. So let's take the easiest point I know of. That's 0, 0. All right, and I'll even highlight it in a different color for you. The origin, 0, 0. And I'll test the point 0, 0 in my inequality. Y is less than negative 1/2 x plus 2. So subbing in an x value of 0 and a y value of 0, I get 0 is less than negative 1/2 times 0 plus 2. And doing some quick math, anything times 0 is 0, leaving me with 0 is less than 2. That is, in fact, a true statement. I know now that my shading is correct. Now, if you wanted to see if your dotted line was correct, you could test a point on that dotted line and prove that the inequality was not true. I can take my point of my y-intercept, and that's that point 0, 2, and I can substitute that in to my inequality, giving me 2 is less than negative 1/2 times 0 plus 2, and I'm left with 2 is greater than 2, which is not true, it's false. And I know that my dotted line is now correct as well, because that point 0, 2 does not satisfy the inequality. Now, to take that one step further, you can pause on this screen if you need to take some things in, but I'm going to move to my next page where I'm going to talk about systems of inequalities, where we actually graph 2. So I'll use the same exact inequality from the first example as my first graph, and then my second one will be y is greater than or equal to 2x minus 4. Now, being that I know how to graph the first one, I'll start with that. I'll start at my y-intercept of 2. I'll go down 1 over 2, down 1 over 2, down 1 over 2, and it's a dotted line. And I know my graph is not the neatest, but it's pretty close. And my graph looks something like that. Now you can label it if you must. I'm going to leave it unlabeled for now, just for neatness purposes. And my second graph, now I have to determine if I'm using a dotted line or a solid line, and if I'm shading above or below. Now it says y is strictly greater than or equal to 2x minus 4. Well, I know for a fact I have a greater than sign, meaning I definitely will shade above. And the line underneath the inequality symbol, making it greater than or equal to, tells me that I now have a solid line, and every point on that line is included in my solution set. So, starting at negative 4 of my y-intercept, I'll graph a slope of up 2 over 1, and I'll get a graph that looks something like that. Now, to talk about my shading, I'm going to use different colors here, just so we designate which shading is for which inequality. Green will be used for my first one, and again, if you recall from that first example, we shaded below my dotted line, or my dashed line. And then I'll use the color blue for my other inequality, y is greater than or equal to 2x minus 4, and we said that we would shade above that line. So there's above. And where the colors overlap, it's that teal color. And that is our actual solution set. Notice I've labeled it with an S, and I can take a point and check to see if it works in both inequalities. So again, I'll take that point, 0, 0. We already know it works in the first inequality because we just checked that in the first problem. I'll check it in my second inequality and see if it holds true. 0 is the value of y, which is greater than or equal to 2 times 0 minus 4. And I have 0 is greater than or equal to negative 4, which is a true statement. That point, 0, 0, is in the solution set, and we know that we've shaded both inequalities correctly. So that's just a brief overview of systems of inequalities and linear inequalities. I hope you guys were able to follow along. If you have any questions, please post in the comments. Make sure to like the video as well. All right, see you guys.